to lecture 59. We have been discussing about the general orbit perturbation theory, and in that context we worked out with the Lagrange bracket and evaluated it, and then found the Lagrange planetary equation of motion, and then thereafter we wanted to describe the instead of perturbation potential, we wanted to use the force, perturbation force, because many times the perturbation potential is not available, but because the force may not be conservative, and in that case you do not have the availability of the potential. So, we have to work with the force. So, that we were trying to convert the potential model into the force model. So, we will continue with that, but before that one equation was left out last time. So, we will complete that. So, there was some sign problem with this bracket. Perhaps there was a minus sign written there. So, the correct sign is as indicated here, okay. And the corresponding equation for the capital omega, where the problem might have occurred. Okay. So, this is given by sin I times okay. So, once again I will write all those equations, so that no confusion remains. Minus 2 by n a dou r by dou sigma, then E dot I dot equal to minus cot I 1 minus C A square C A square sin I dou r by dou capital omega and sigma dot this equal to 1 minus C A square So, we have 4 equations here, A dot E dot, okay, small omega dot is remaining. So, small omega dot, this is cot I okay, rest this sigma dot also it can be expressed in terms of m dot, and it can be written as m dot equal to where m dot is the rate of change of the mean anomaly, n is the mean angular velocity or the mean angular rate. This implies that you are keeping m constant. Whenever we put in bracket some partial differential and put like this, so that means you are keeping m constant, and then you are finding this. So, either this or this, either of them can be used. Now, here in this part what we were trying last time, that all these terms appearing here these need to be replaced in terms of we have replaced in terms of we were trying to replace in terms of f r, f theta and f a, where f we have described as f r times u r cap, then f theta times u theta cap and f a times u a cap. So, the development we were following. So, I will go along with those developments, but before that I will summarize these equations. So, that it is ready for your reference. In terms of can be written as see this was our Lagrange planetary equation of motion. Okay, so, dou r by dou sigma if we replace in terms of f r, f theta, f a. So, this will get reduced to the format 2 e sin theta f r plus 1 minus c a square f r, then a dot already we have worked out for the dou r by dou sigma. Actually, what we have done the last time we have worked out what will be the equation for the f r. Okay, I will do it again. Let's see. First, we finish this sin u n a square 1 minus c a square sin I times f a, where u equal to omega plus theta. One minus c a square f theta. So, these are the 4 equations and last 2 are So, these are the 6 equations which are once converted in terms of f r, f theta and this f a. So, this is how they appear. Okay, so, now we start with what we have been doing. So, what we did that we represented the reference frame first x y z, and in that then we had the orbit, the projection of the orbit represented like this. Then we had in this direction a p cap unit vector we have taken in the direction of xi, and then in the direction of q cap we have taken the eta. So, this is the reference frame in the plane of the orbit, and then we indicated the satellite position somewhere. So, along this direction we had the vector u r, perpendicular to this we have u theta, where the angle theta is indicated like this, and this angle we have represented as a small omega, this angle as capital omega, and angle of inclination, this angle is I, inclination with the x y plane of the orbit, inclination of the orbit with the x y plane. Okay. So, and then we had with other color we can show it. And perpendicular to this then we have u a. So, where u theta cap u r cap cross u theta cap equal to u a cap. So, these are perpendicular, means if you have u r here, this is u theta. So, u a cap is up. This angle is 90 degree, this angle also 90 degree, this angle is also 90 degree. And then what we were trying to do is that we wrote f as f r u r cap, f theta u theta cap, and f a u a cap, and dou r by dou C j we wrote it this way. And this quantity is nothing but minus f. So, force of perturbation on the ITS particle or the ITS planetary body, assuming it to be a point mass, and then of course, we have dou r by dou C j, and what we were trying to do is find out this quantity, because f is already described here in this format. So, we have to find out dou r by dou C j, and once we do this, so we can take the dot product and this quantity will be available to us. Where I r I was minus g j equal to 2 to n, j not equal to y, and then r j whole cube. So, different models are required in different places. Say if we are looking for aerodynamic drag. So, aerodynamic drag always by convention, say if this is the orbit, and then at any point the velocity will be tangent to this. So, velocity tangent we can show it like this. So, this is the velocity direction, and therefore, drag will be opposite to this. This is by convention. Okay. And therefore, we need to find out the force along the tangent direction, while here this is not along the tangent direction. So, in this case it may be helpful to work with the other representation, like here we can have in the tangent direction we can have u t as the unit vector, and perpendicular to this then we will have u n as the unit vector, and to perpendicular to u t and u n we will have another vector which we can name anything, like say I name it u c or whatever. Okay. So, here in this case the drag will be modeled if properly, if we represent this in terms of the tangent vector, unit vector, and normal to this is called the principal normal, and the what is appearing here as the u c, this is called the binormal. Okay. So, along the tangent direction, along the principal normal direction, and in the binormal direction we require then all the forces. So, this model also we will look into shortly once we finish this part. So, let us go ahead and finish this part first, because each every model it is useful in its own place. It depends on the situation which will be more convenient to represent. Okay. Okay, so, thereafter we represented u r vector and u theta vector and u a vector. This we represented in terms of capital omega, small omega and I. So, these were function of capital omega, small omega and I. I will not repeat those equations again. So, u r cap, say this is something times it was I cap, then j cap and then k cap. Similarly, u theta cap was described. And the same way the u a cap also it was written. Okay. So, thereafter we wrote r as xi times eta p cap plus xi times p cap plus eta times q cap, and this model we have used earlier while evaluating the Lagrange bracket. And here we have the xi as a times cos e minus e and eta as a times 1 minus e square sin e. And what we require? We require this quantity dou r by dou c j. So, therefore, the first example we took of it was dou r by dou a, and from this place then we wrote it this way q cap, and thereafter we evaluated this term. So, in that context we got dou r by dou a as the quantity minus f r r by a. Okay, so, till this extent we have done last time. And where this will go? This will go into the equation we have written earlier, dou r by dou a, you see where it is appearing. So, in those places we need to insert it. Here in this place this is not there, here it is not there, here also it is not there, here also not. So, dou r by dou a is present here in this place. So, we need to insert it here in this place. Okay. Now, once we have done this, the other part, then one more I will do, which is dou xi by dou e, because each of the derivation it is a quite cumbersome and it is a long. So, it is not possible to carry out all the things here in the class. So, this will come as the supplementary material later on. Okay. So, this quantity is what? This we have to derive. So, again we start writing xi equal to a times cos e minus e, and therefore, we can see from this place that dou xi by dou e, how much this quantity will be. So, this is a times, here e will be, this is minus 1 once we differentiate, and this will be cos e once we differentiate, this will be sin e dou e by dou e. And why we are differentiating this? Because we have m equal to e minus e sin e, okay. And m is the quantity which is written as n t minus capital T, where capital T is a constant, and therefore, once we differentiate and m is also okay. So, dou m by, first we write this dou m by dou e, this quantity will be, now here if we look into, n is a function of n equal to mu by a cube under root. So, n is not a function of e, okay. Only a is appearing, and therefore, this quantity is 0. So, once we differentiate this quantity, so dou m by dou e equal to 0, this will be equal to 1 minus, and then we are differentiating with respect to sorry, this is we are differentiating with respect to small e, and therefore, this will be dou e by dou e minus sin e and minus e cos e, and therefore, now if times dou e by dou e, we combine the terms together and write it. So, this okay. So, from here we have dou e by dou e times 1 minus e cos e, this equal to sin e with minus sign. Okay, let me write it here. This place is getting short. So, m we have chosen as written as m e sin e, and because m is a function of mean angular velocity minus t and mean angular velocity, and then we are differentiating this with respect to e. So, this quantity will be 0, because here these are not function of e. So, the left hand side then we have set it to 0 and then work with the rest of the things. So, therefore, dou m by dou E this equal to dou by dou E minus E sin E, and then once we expand it. So, this will be dou E by dou E, dou capital E by dou small e minus sin E, and then minus E times cos E, and this we combine and write it as, here we have 1 minus sin E, this will be plus. So, the same thing I am writing here in a little better way, dou E by dou E 1 minus E cos E minus sin E, and this quantity is 0, and this implies dou E by dou E equal to sin E divided by 1 minus E cos E, and this is the equation we are going to utilize. Now, we have to work with this equation. We have to find out what will be the dou xi by dou A and dou eta by dou A. So, we look for dou xi by dou A. This quantity, because xi is A times cos E minus cos capital E minus E, and therefore, once we differentiate this, we can write it as per A times so this is the quantity already we have worked out on the last page. Okay. So, we need to insert that value, sin E, and dou, this is sin E by 1 minus cos E. So, this is sin E by 1 minus cos E. One more point, this is a small e is missing. So, we have here a small e also present, in this place also small e is there. And we recast this equation into little different form, so that solution to the problem becomes little easier. Okay, if we take it A inside, now A sin E, if you remember, eta we have written as equal to r sin theta is equal to A times 1 minus E square sin E. So, A sin E, this quantity is r sin theta divided by 1 minus E square under root. So, A sin E we will replace by r sin theta divided by 1 minus E square under root, then sin E, and rest of the term we have to copy here. So, let us say this is our equation A. The same way we have to work out the eta term. So, eta is A times 1 minus C A square sin E, and therefore, dou eta by dou E, this quantity will be A times 1 minus E A square times minus 2 E to cancels out, this is E sin E with minus sign here, and then the other term, this is plus A times 1 minus C A square dou E by dou E. So, we need to replace this quantity dou E by dou E, already we have written on the previous page, sin E by 1 minus E cos E Okay, again some of the terms we will change and write it in a proper format. Therefore, we have dou eta by dou E, this equal to the first term here. If you see A 1 minus C A square sin E is appearing. So, this quantity is nothing but r sin theta. Okay. So, we replace the second term will be replaced by r sin theta. Okay. First, we take into account this part. So, A sin E is already we have written here. A sin E we will replace with r sin theta divided by 1 minus C A square. So, so the first term then gets reduced to, see here itself, let me do it. So, it will be convenient for me to work out, minus A sin E is r sin theta divided by 1 minus C A square. So, r sin theta A we have taken, this is E r, and then 1 minus E A square. 1 minus E A square is already there, and this makes it 1 minus E A square here, and plus this part A times 1 minus E A square sin E from this place, this is r sin theta. So, this becomes r sin theta times cos E divided by 1 minus E cos E. So, r sin theta cos E 1 minus E cos E 1 minus E A square. So, let us summarize it here. So, this becomes r sin theta cos E times 1 minus E cos E Now, we can utilize these terms in finding out dou r by dou E, which we have written as dou xi by dou E p cap plus dou eta by dou E q cap. So, inserting the values p cap and q cap, it is available to us. We have p cap equal to u r cos theta minus u theta cap sin theta. Already we have worked out these things in the previous lecture. So, we will utilize this information here in this place. this term we are picking up dou xi by dou a square sin e 1 minus e cos e, and we have replaced a sin e is 1 minus r square Okay, one more replacement it is possible here in this place, and we can, because later on again we will have to replace that term. So, better we do it here in this place itself. This sin e also from this place, if you see sin e, we can write it as r a. So, here this becomes then the r square sin square theta divided by a times 1 minus e square 1 minus e cos e. So, from this equation let us write this as a prime. Okay. So, this equation will be required, either we replace right in the beginning or later on, but it is required. Okay. So, r square sin theta a times 1 minus e square and then 1 minus e cos e. Times p cap, which is nothing but u r cap cos theta minus and plus then dou eta by dou e. So, the term which is here. So, r sin theta cos e minus e r sin theta, and this then multiplied by u r cap theta cos theta. Okay. So, we will continue with the same equation in the next lecture. We stop it here. Thank you very much.